Welcome back to our SQL learning session. Today we'll be talking about hierarchical queries from Database for Developers. In this lesson, we have 13 sections. This lesson has been implemented using proprietary Oracle Connect By as well as ANSI compliant recursive with. I'll be mainly focusing on ANSI compliant version steps, then Oracle native or Oracle proprietary steps, because ANSI compliant is widely used in any can be widely used in any database, and it is more easy to learn. Starting with introduction, you can use hierarchical queries to travel along patient-child relationship in your data. For example, family trees, computer directory structure, company organization charts. This tutorial shows method to build org charts using following sample company. Here's a company for employees. Let me run this. Let me run the prerequisite SQL. Let me restart it. I'm restarting the SQL such that I can run it. SQL has been restarted. Now let's run this. Prerequisite SQL. It's running now. Now let me run this query. This query has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. This query has 14 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. 11 columns and 14 rows. Now let's learn about recursive with, that is section 4. We'll be skipping section 2 and section 3 and directly jumping to section 4. Oracle Database 11.2 introduced another method for accessing trees, recursive subquery factoring, also known as recursive with. This is an ANSI compliant way to build hierarchies in SQL. It is composed of two queries, a base query and recursive one. Base query. Use this query to define a root rows in a tree. It is like a start with clause in a connect by. So to begin the chart with CO, use this query. Here's a base query. Let's run this and see what we get. Now, this will give you the CEO of the company because it has no manager. When you use recursive with, you must provide aliases for all columns it returns. This goes between query name and as. Now, let's talk about recursive with. When you do recursive with, it starts with, it's a CTE, but it also has column names of the table. Here's a query. The first one is a base query and second one is a recursive query that refers the city itself. The recursive city itself, which is the org chart, and org chart has a column names. Now, if you run this, it should give us the recursive query, starting with the null CO, and just digs down from there on. And this is a breadth first search. Breadth first search starts with the CEO and gives all the child of the CEO or the reports to the CEO, and then goes to the first person who reports to you and looks who reports to that person. And Nancy Greenberg reports to 101. And for 102, we have a 103, that is Alexander Hunruld. In this way, this is a breadth wide search. Now, let's try to do an exercise here. In this exercise, we need to write a query to build a reverse org chart from step 3 again, but this time using recursive word. It should start with employee ID 107, go up the company to CEO. As in model 3, employee is a parent row, their manager is a child. Now this is a inverted org chart, therefore employee is a parent and the manager is a child. How to do this? Looking at this query, can you tell me what needs to be done to get the result we want? Let me show you. The query asks that we should start with employee ID 107. Therefore, we'll do where employee ID is equal to 107. That's what we are looking for here. This is employee 107, the lowest employee here. Next, what we need to do is we need to join org chart with employee such that org chart with employee such that employee is a parent row and manager is a child. And we need to look at the manager from this. We need to join the manager from employee the manager ID of the employee should be equal to org chart dot employee ID. And what it's doing, it gives you the first employee 107 and it'll look at the manager of that particular employee and that should be equal to the some employee of the org chart. In this way, it recurs down inversely from then onwards. Let's run this. It is not giving any result. Maybe we need to take the employee ID here and switch it up with manager ID. Maybe this will work. Let's check. And this is what exactly we need. What we did was we gave you the first of all we have the employee and we took that employee and checked uh, who is this manager in the org chart and then get that person, took the employee ID of that person and found out who is the manager of that. And in this way, we went up to the food chain. And thus we found the result we need. Section 6 is about Oracle proprietary information. Therefore, we'll skip that. Uh, uh, Level 6 is can be done by using two different ways. One is Oracle proprietary connect by, and one is using a ANSI compliant recursive with. Level with the query so far, it's hard to tell how senior someone is in the company. Adding a generation they belong to makes it easier. This allows you to see who's at the same level in the hierarchy. how do you do this depend on whether you are using connect by or recursive with. We'll skip connect by, it's a proprietary oracle. We'll focus on recursive with. Recursive with doesn't have an inbuilt equivalent level. You need to build your own. You can do this by selecting a value 1 in a base query and incrementing by 1 in a recursive part. For example, here's an example. Yeah, we have our base query and we have a one more column where it is called level and it is 1 here. But when we do the recursive query, on top of it, add, we'll add, we will add, we'll add a OC, it's an honor column, and add 1 on top of that. In this way, we just go down the food chain and adding the level 1 to the same people who are the same level. Now let's run this query. It's a breadth first search. These two are on the same level. This person is in the same level. And these 4 people are on the same level. Section 7. Section 7. When you build a hierarchical query, database returns row in order matching the tree structure. Connect by returns rows in the depth first search order. Connect by returns depth first search. If you use a regular order by, you lose this sort. But you can preserve a depth first search tree and sorting rows with the same parent. This section 7 is purely related to Oracle Native. Therefore, we'll skip this one. Now, sorting the output using recursive with. Recursive with allows you to choose you want to whether you want to traverse the tree using depth first or breadth first search. Breadth first search is the default, while depth first search is you can define that. Depth first search. This starts at the root. Then pick up the one of its children, then it gets a child's child, and so on. Down the tree, accessing child nodes first. When it hits the leaf, it goes back up the tree until it finds an unvisited child. So it's always goes far down the tree it can before accessing another row at the same level. To use the depth first search, specify this in a class search class. The columns you sort by defines which order the database returns siblings. The set clause defines a new column sorting sequence. Starts with 1, add for the first root. At each new row, it increments by 1. So we return employees at the same depth first. Sorting employees with same manager by date they were hired. Use this. Search depth, search depth first by hire date at set hire sequence. Here we are using depth first search and we are sorting by hire date. And we are generating a sequence called hire sequence, which we will sort by in order by. Now here's a SQL implemented in that way. We have a base query here starting with the first level, and second we are creating a recursive with and adding a 1 to the level to each level, and we are doing depth first search where we are doing when we do depth first search, we are just mentioning that we want to if the people in the same level should be sorted by hire date and we need to generate a hire sequence. Let's delete this and see what we get just for heck of it. We need this and we will use to we are sorting by hire sequence. This means if the if the person is hired later, then his sequence will come later, and if person is hired early, then his sequence will come earlier. And it is used to sequence the people in the same order. What we do descending here, let's do descending here. What would happen here? What's happening here is that we are putting the latest hardware first at the same label, and we are putting who's higher earliest at the later. In that sequence, we are putting it out. Breadth first search. Instead of traveling down the tree, you can go across it. It is a default way of doing it. This starts with the root, but it accesses all the rows at the same level before you go down to any children. So if you have any roots, it will visit all these first, then all the first generation children before going down to the second generation and so on. Sorting column define which order you want to access node at the same depth. Unlike depth first search, successive rows at the same level may alternate between parent row. So the following returns all the employees at the same rank next to each other. It sorts this by their hire date, first to last. Here, this is what we need. This is a first base query, and this is a second query, where we are adding the label on top of that, and we are going searching by breadth first search, and if it's the same label, we are sequencing it by hire date. The hire date should come at first. Breadth first search is a default way to search in the database. Now let's try an exercise, section 9. Here we need to complete a query to return employees in a depth first search order. You should sort employees with the same manager by first name. Here's a partially filled query which you need to fill out to get the result we need. Can you look at this query and see what needs to be done to get the result we need? Let me show you. Here, we are being asked to sort employees with the same manager by first name. Same manager by first name. Now, this is done in the SQL. This is done in the Oracle native way, but we want to do in more NC compliant way. Now let's modify this and do it in NC compliant way. We need to search, do the depth first search. That means it should be this one. This is a depth first search by 100. Now, what we are interested in, if it's the same label, we want to order by the first name of the person. The first name of the person is employee's first name. Employee first name, and we'll call, heck of it, we'll call name sequence. And let's sort by name sequence. And let's see what we get. Invalid identifier. There's some issue here and trying to fix the issue. Now we need to modify the Bradford search by first name, not the hard name. Let's do it by first name. Here we have a higher sequence. Now it's called name sequence. Let's name it a name sequence. Now let's rename it by name sequence and let's see what we get. And this is exactly what we need. People who are at the same level should be sorted by their name first, the first name. These two people are the same level, so L comes before N. These two people comes in the same level, so A comes before N. In this way, we have sorted by people at the same level with by their name. And this is exactly what we need. Now, moving on to 10, detecting loops. It's possible to store loops in your hierarchy. Using this is a usually this is a data error, but some structure usually may contain loops by design. For example, following sets a CEO's manager to be lowly programmer. This is a data error. Now let's update the table employee such that the manager of CEO is some programmer in a company. This is a circle in the data, so you could get stuck in infinite loop. Luckily, Oracle database has cycle detection to stop this. But we are not using Oracle way, but we are using recursive way. You can control loop detection using cycle class of recursive width. Here, you state which column marks a loop. The database keeps a track of values it sees in these columns. If the current row's values for these appear in one of its ancestors, you have a loop. The syntax for this is cycle, the column you want to keep track of, and the loop column where will present the indicator of whether loop exists or not, and the loop value we want to change it to from default. The loop column is a new column you define. When database detects a cycle, it changes this from default to a loop value. Oakchart has loop if you visit the same employee twice. So you want to check this column for cycles. The snippet below does this and adds a column loop in your result. This starts with a value n. If database finds a cycle, it says to y. Here's an example. Cycle employee set looped to y default 10. Here's a SQL that has implemented this snippet. We have the first CEO whose employee ID is 100 and is the CEO of a company, and we have the recursive width. Now we are cycling through we are putting a cycle clause where we are checking for employee ID and we are creating a new column called looped whose default value is n, but we change it to y if we detect the loop and select from root from org chart. Now if you run this, when it detects the loop, it stops. Unlike connect by, this includes a row you visit twice. It includes a row you visit twice. So the CEO Stephen King appears twice as a result. If you want to exclude this, filter them out in your final result where clause using loopcom you define. I can filter it out using with the where clause where the loop is equal to no. This is the purpose of this is to filter it out. Now we have filtered it out. Unlike Connect By, this includes the rows you see twice. So CEO Stephen King appears twice in the result. If you want to exclude these, filter them out in your final value where using loop column you define. Using recursive width, you can choose any column in your query to mark a loop. This allows you to stop processing before you get back to the same row. For example, you can cycle on department ID. The CEO's direct report, Nina Kochar and Lex Dehan are in the same department as him. If you cycle a department ID, like cycle department ID, set loop to y default n, then it will show you this result. Here's a SQL that implement this logic. It will only show you three results because the next two are loop. And since department ID is repeated, it will show you the loop, but you can filter them out using loop equal to y equal to n. This can be useful to detect rows with two parents. Without cycle detection, you may access a row and all of its children twice. A cycle clause allows you to avoid this. Connect By doesn't have an inbuilt way to do this. Now let's remedy what we did before and set it back to now before we moving on to exercise. Section 11. Complete the following query. It is an exercise now. Complete the following query to cycle on job ID. Define cycle column is repeat which defaults to n. When accessing same job ID twice, you set it to y. Here's a partially filled query. Looking at this query, can you tell me what needs to be done to get the result we need? Let me show you. Here, we need to fill out this query and we need to monitor the column called job ID. We monitor a column called job ID such that and set a new column called is repeat. Which sets to which goes to 1, goes to yes, but default is n. Now let's run this. Here, this is a job ID that's been repeated. And if we filter this out, then we can avoid all those repeated values where is repeat equal to no. And this will filter out those values. Connect By, displaying trees details, Connect By. Since this is a Oracle native, we'll just skip this. Section 13, displaying trees details, recursive width. This is ANSI compliant, therefore we'll go through it. Recursive width doesn't have built-in options like Connect By, or you can emulate them. Values from root. To return a value from parent row, select it in the base query. In the recursive part, return this column from the column clause name. Now here's the implementation of that. Here, we want to return a value from the parent. Now what we have done here is we have defined a new column called last name chart. Last name chart and last name one. And in recursive part, return this column from the clause name. with class name. Now in the recursive part, what we have done is we have taken the root root employer name in this one, and we have appended the chart with the new last name, and we have also appended the label from the root. In this way, either we can keep the from the root or we can just keep on adding from the root. That's how you do it. Secondly, showing the path from root to current row. Again, start by selecting value you want in the base query. In recursive part, append the values you want to add with the appropriate separator. We have the value we want to add in the chart, and we are adding from the base query, we're adding on top of that, or everything we want to add to that column. Identifying leaves. Displaying leaf row is more complex with recursive width. To find these, the depth level and add to the depth level tree. Then sort using depth first search. Depth first search always goes down far down to tree it can. After hitting a leaf, it goes back up to the next unvisited child. So you know a row is a leaf if its next row is the same or higher than a same or higher than a depth in the tree. So you need to check if the next row level is less than or equal to the current. You can test for this using lead. This gets a value from next row in the result. Therefore, here we need to use a lead. Lead. It takes a label and looks beyond. See what's after the current label. It goes one step beyond. If it is null, if it's null, there's nothing no more. Then it says label is 1, and it does by sequence, where you are using as a sequence ID generated using the employee ID. That is, we are doing depth first search, and it's the same label. We are organizing by employee ID, and it is sequence. That's what we are using here. We are using the sequence as a sequencer ID, and we are going over sequence and see if the next sequence has the same label or less than the current. If it's less than the current or same as the current, then it is a leaf. This gets a value from next row in result. Assuming sequence follows a depth first search, the following returns leaf if the row is a leaf, or else it returns null. Now let's run this here. It is returning leaf because it checks its value and goes to the next sequence and sees that this next level is still 4, and why this is leaf? Its next level is less than current level. That means it's also leaf. In this way, it is determining whether the current node is leaf or not. In the end, let me quickly summarize what we learned today. We learned about hierarchical queries. We talked about recursive width, sorting output with recursive width, detecting loops, and displaying trees using recursive width. So that's all for today. I'll see you next learning session. Thank you so much.